Greetings, one and all, and welcome to this math video. And in this math video, we'll be considering a vectors question. And note that before us, we have the following. It states that the vector OX and the vector OY are position vectors relative to the origin O. Now, when they say that these vectors are position vectors, what that means is that their initial point, right? That means that their initial point, the initial point of these vectors is at the origin. So here we have the vector OX, and notice that its initial point or its tail is at the origin. And so because of that, we call it a position vector. The same thing for the vector OY. Notice that its initial point is at the origin or its tail is at the origin, and so we call it a position vector. So vector OX and vector OY, so vector OX, which is here, and vector OY are position vectors. So vectors OX and OY are position vectors relative to the origin, and they're saying we have given you the points x equals to 3, -5, so that's the coordinates of the point x, and the coordinates of the point y is -2 and 7. And so they're saying, in light of that information, we want you to write OX and OY as column vectors. So how do we do that? Notice that they have given us the coordinates of these vectors. So they have given us the vectors, they've given us the point. I should say that they have given us the coordinates of the points. And the coordinates of the points for x, it is 3 and -5. All right? And for y, the coordinate of the point y is -2 and 7. -2 and 7. And so notice that the orientation of this point is horizontal, right? It's in a row form, right? So it's horizontal. It's in a row form. But they're saying write it as a column. So they're saying change the orientation of this thing that we have here. Change it from a row orientation into a column orientation. And so they want us to change it from looking like this to looking like this. So they want us to represent this, they want us to change the orientation of this into its column, into a column representation. All right, so let's do that. Let us take this point and change its orientation. And so if we do that, it will look like this. So we'll have 3 at the top, where we have 3 at the top, and we have -5 at the bottom. And so that's the vector OX. All it is that you're changing the orientation from row orientation into column orientation. The same thing occurs for OY, right? So OY would be -2 and 7. And so from a row, we're changing it from a row orientation or from a row form into a into a column form. And so we have -2 and 7. Okay, so that is how we write OX and OY as column vectors, changing it from row orientation to column orientation, shifting it. Okay, let's consider the next question. And here they want us to express XY as a column vector. So they want us to express XY as a column vector. But what is XY? Now can we find XY? Let's consider this diagram here. And again, here we have here we have the vector OX, all right? But even before we consider the vector OX, we have the point X, and the point X is 3 and -5. That's what we have here. And the point Y is -2 and 7. So that's the point there. So the vector OX would be this vector here, and the vector OY would be this vector here. But where's the vector XY? The vector xy means that we're going to start at x, we're going to get to y. And so that is the vector xy right here, represented in red. And so the question is, how can we start at x and get at y without passing through this red line? How can we do that? Well, what we first can do is we can first start from x and then go to O. And then from O, we're going to go to y. And so let's do that. We start, xy is going to be equal to xo. So we start at x and go to O. And then we move from O to y. And that's what we have here. Now notice that OX, the vector OX, is going downward. But we want the vector XO, and the vector XO is going in the opposite direction. All right, it's going in the opposite direction. So that's why we have a negative. So XO equals negative OX, and the negative is there because we're going in the opposite direction. Now we bring down the OY, place it there. And so what do we do? What is OX? Remember from the previous question, OX written as a column vector is 3, negative 5. And so let's substitute that in there. So OX equals to 3, negative 5. And we cannot forget our negative sign. Plus OY. What is OY? Well, from our previous question, we know that OY is negative 2 and 7. Okay, so let's substitute that in. So OY is negative 2 and 7. And OX is 3, negative 5. And again, we cannot forget our negative sign. Now, we have the negative sign, and we can look at this as negative 1. And so we consider negative 1 multiplied by 3. And what is negative 1 times 3? Well, that's simply negative 3. And we have negative 1 times 5, which is simply positive 5, because a negative and a negative becomes a positive. Okay, now we can add these factors. And so we add corresponding entries. So we're going to add the top by the top and the bottom by the bottom. So what is negative 3 plus negative 2? Now, negative 3 plus negative 2 is indeed negative 5, because you can look at it as saying you owe someone $3 and you owe another person $2. How much do you owe in total? Well, you owe in total $5. And so that's negative 5. And we're considering 5 plus 7. And what is 5 plus 7? 5 plus 7 is indeed 12. 7, 8, 9, 10, 11, 12. Okay, so that means that the vector xy written as a column vector is negative 5 and 12. Now let's consider the last question in this. They want us, which is C, and they want us here to calculate the magnitude of xy. And here they made an error. The correct symbol for magnitude is this symbol. So we need to put those vertical bars there. So that's correct. Calculate the magnitude of xy. So how do we calculate the magnitude of xy? We're going to do that right now. Notice that xy is equal to negative 5 and 12, which we saw in the previous question. And in order to find the magnitude of xy, and this is the symbol for magnitude of xy, what we do is we take negative 5 and we square it. So you take the top number and you square it. And you take the bottom number and you also square it. So what is negative 5 squared? Well, that's simply negative 5 times negative 5. And negative 5 times negative 5 is positive 25. And the same thing here, 12 times 12. Well, 12 times 12 is 144. And let's add these two. What is 144 plus 25? That's indeed 169. And now we want to find out the square root of 169. That is, which number we can use to multiply by itself to give us 69. 169. And indeed, that number is 13, because 13 times 13 is indeed 169. So therefore, the square root of 169 is indeed 13. So the magnitude of xy is going to equal to, the magnitude of xy is equal to 13. And so that brings us to the end of this video. We have completed all 3 questions, and thank you for your time and attention, and I'll see you in the next video.